Hey guys, I'm going to run you through this worksheet. A couple questions come up on the Google Classroom. So sorry it's taken me so long. I've been pumping out a few YouTube videos for all my classes lately, and just got up. I just saw this sheet. I need to go through it. So question 1. So if you haven't done the sheet now, would be a good time to pause it and give it a crack before I run through the answers. So question 1. Well, we're dealing with opposite sides and opposite angles, and it's a side we want. So using the sine rule, so A over sine A is B over sine B. So if we call this angle A inside A, angle B inside B, then we're going to have 15 over sine 31 equals x over sine 51. And to get x by itself, we just times by this denominator. So 15 sine 51 over sine 31 equals x. And so if we punch that in our calculator, don't need anything fancy, just a standard scientific calculator, we get 15 sine 51, and then we divide that by sine 31, 22.6, and that's meters. Easy as that. Question 2, am I dealing with opposite angles and sides? I am, and it's an angle I want. So this time I'm going to use sine A over A is sine B over B. So I'm using the sine rule, but it's up the other way because I'm trying to find an angle. So if we go A, B, B, so dealing with opposites, I can plug in here. So let's take sine theta over its opposite side. That's going to be sine 45 divided by its opposite side, 12. And this is why we have the two different formulas, because we want this unknown to be on the top. Because all we have to do now is times by the 14. It's 14 sine 45 over 12. And then you guys know from year 10, 11, to undo a trig function, it's sine inverse. So I take the sine inverse of that whole thing. And that's going to be, let's go 14 sine 45 first. Cool. Divide that by 12. And now let's take the inverse. So shift sine, and we'll put that answer in. And 55.6. And the units are degrees. It's an angle. We've found our angle, 55.6 degrees. Cool. So the other rule that we've been working with is the cosine rule, and this is cosine rule finding a side. So if this is A, B, C, and that's going to be capital A because we always label with opposites, then finding a side comes out to be A squared is B squared plus C squared minus 2BC cosine A. So x squared is 32 squared plus 24 squared. Take away 2 times 32 times 24 times cosine 22 degrees. I'm just going to chuck all of it in my calculator. I'll pretty much do that in one go. So 32 squared plus 24 squared, take away 2 times 32 times 24 times cosine of 22, and that's 175.9. Last step, I just need to square root. So I bring this back, square root that answer, I get 13.3. millimeters. So when you do these problems, just ask yourself if the answer makes sense. So we've got 24, that should have been millimeters as well. We've got 24 and 32, and we've got a really small angle. That's a really small angle. So we'd expect this length to be not very long. So 13.3 sounds about right. Okay, this is sometimes the challenging one. We're finding an angle. So if this is angle A, that's side A. And then it doesn't matter what way we label those, they're B and C. So if we're finding cosine theta, well, that's going to be A squared minus B squared. Oh, sorry, that's going to be B squared plus C squared minus A squared all over 2BC. So cosine theta is going to be B squared plus C squared. Try to write this a bit clearer. 14 squared minus A squared all over 2 times B times C. So cosine theta looks like this. 14 squared plus 19 squared minus 22 squared. That's on top. Now we divide by 2 times 14 times 19. And we get 0.1372. 0.137218. Might as well put a few in. And then I need to cosine inverse that. So theta is cosine inverse that answer. 82.1 degrees. Nice. So that is that angle, and it kind of makes sense too, right? Got 22 along here, 14 and 19. It is going to be quite a broad angle. Question 5 is a little tricky, but it's just 2 of these steps combined, isn't it? So if I was to find this length of that line down there, okay, so if I was going to find this red line, once I had that red line, I'd be able to do exactly what I did here to find the angle. And to find that red line, I just do exactly what I've done here to find that. So I'm going to communicate my working and say red line length, and that's going to be cosine rule. So this side here, let's just call it x. X squared is b squared plus c squared minus 2 times b times c times cosine of that angle. So this goes all the way through my calculator in one big go. I've got 8.3 squared plus 10.3 squared. Take away 2 times 10.3 times 8.3 times cosine 108 degrees. And so that is 227.8. And then if I square root that, I get x by itself. So x is 15.1. Units aren't too important here, but it is meters, isn't it? And now I'm finding theta. So, and that's going to be this rule here. So cosine theta, b squared plus c squared minus a squared over 2bc. I'm going to be using that rule. So cosine theta is going to be b squared, 15.2 squared, plus c squared, 12.1 squared, minus a squared. So minus 227.8 actually, isn't it? But we'll go minus 15.1 squared all over 2 times b times c. Put that in our calculator. What do we get? 15.2 squared plus 12.1 squared minus 15.1 squared. That's on top. Now I divide that by 2 times 15.2 times 12.1, and I've got 0.406. So 0.4062636. So if we take cosine inverse of that number, we get 66 degrees, 66.0 degrees. And that's more in line with a pretty standard Year 12 trig problem. They are usually multi-step, especially if you're going for those higher grades. Alright, hopefully that helped. Hopefully you can read all of that. Didn't give myself a lot of room. Any questions, you need to be hitting me up.